Binary split.
So it supports only binary split. So Gini index supports mainly binary split. That's why here only for any given attribute, if at all it is continuous, we need to go for split point. If at all it is discrete, we need to go for what? If at all the attribute is discrete, then then we need to go for
Splitting subsets, no.
splitting subset. So those two are the only options we have, right? And next, and in the last class, I have given some assignment also. And since the participants are only 25, I will ask about that in the middle of the class or at the end of the class. Okay, let me proceed with the remaining topics. And coming to the summary of the attribute selection methods, here we are having broadly 3 attribute selection methods: information gain, gain ratio, and Gini index. So in information gain, we have some drawback, that is, it is biased towards multi-valued attributes. So that's why we go for the gain ratio. So it adjusts the bias little bit. It tends to, but it tends to prefer unbalanced split, in which one partition is much smaller than the other. So if you go for information gain ratio, its drawback is that it is biased towards the unbalanced. That means it results in a unbalanced split, unbalanced partitions. So the third one is Gini index. It is also biased towards the multi-valued attributes and has difficulty when the number of classes is large. It also tends to favor tests that results in equal size partitions and purity in both partitions. So if you see here, each measure is good in its own way or bad in its own way. So each measure has its own importance and depends upon the problem we have considered. Depends upon the data set we have. We can go for any of the 3 measures which we have seen. And coming to the last topic of the decision tree. Wait a second. Tree pruning. So just observe the images here. What is meant by tree pruning? What you get by observing the images projected here? Just by seeing the images, what you get? Anybody? Something, this topic is related to that pictures which we have presented on the screen. What is that? What is meant by tree pruning? Somebody speak out. Number So what is meant by tree pruning? What you get from these images? Number 6. Number 6 is there or not?
Yes, ma'am.
What you get from these images? జస్ట్ ఈ ఇమేజెస్ ని చూస్తే మీకు ఏమర్థం అవుతుంది?
అది కట్ చేస్తున్నారు మేడం కొమ్మలు.
ట్రీని కట్ చేస్తున్నారు. జనరల్ గా ఎందుకు చేస్తారు అది? ఎనీ ఐడియా? ఎనీబడి? నెంబర్ 7. Number 7.
Ma'am,
Why they are doing that?
growth బాగుండడానికి.
For getting the good growth, along with that, for getting the good look. Okay, you can mute. More disturbance from your side. So, as said by number 6 and 7, generally, why we are doing that? Why gardening people, the one who performing gardening activities, they usually doing that regularly. So, what is the purpose? As said by number 7, for having a good growth of the tree, and also for having a good looking. So by cutting the unnecessary leaves or unnecessary edges will leads to the good growth of the tree. Everybody agree with it, or any other reason is there? Number 10. Number 10.
Yes, ma'am. Yes, ma'am.
Is there any other reason for cutting the tree edges, or for time pass they are doing? తెలీదా? టైం పాస్ చేస్తారా లేదంటే ఏదైనా రీజన్ వల్ల చేస్తారా తెలీదా? So here tree pruning is nothing but cutting the edges of the tree, in general sense. In general sense, cutting the edges of the tree, as you observe in the figures. Generally, the gardening persons usually frequently try to cut out the extra edges, some branches, some leaves of the tree, which helps the tree to grow perfectly with a good shape and with a good health actually. So to grow the healthy tree, they are doing this. So here also since we are in the concept of decision trees, here also there is a concept called tree pruning. Here also there is a concept called tree pruning, and in tree pruning we are going to cut some branches of the tree, so which helps us to generate the efficient decision trees, which actually helps us to generate the efficient decision trees, which also helps to get the result faster. That means which increases the efficiency, which increases speed of generating the output, etc., etc. Why to cut the branches of the tree? Branches of the decision tree, in the sense, even though you have go through the process of pre-processing before construction of the classifier, I told you in the previous classes also, even though you have performed the initial pre-processing, still some noise, some outliers maybe exist in the dataset. Still, some noise or some outliers maybe exist in the dataset. Because of that, some unnecessary branches may be generated. Some unnecessary branches may be generated from the tree, which should be avoided. So that process is known as tree pruning. That process is known as tree pruning. Just wait a second. So here, just I'm going to read out the sentences. You just try to map these lines with the picture which you have identified in the figure, in the PPT. So when a decision tree is built, many of the branches will reflect anomalies in the training data due to noise or outliers. So tree pruning methods addresses this problem of overfitting the data. Such methods typically use statistical methods to remove the least reliable branches. So here we have used some statistical methods to remove the least reliable branches. That means the branches which are not reliable, which are something which include some noise or which are unnecessary, which are uncertain. Those can be removed based on some statistical methods. So in case of a normal tree, there is no method. By just watching, by observing the tree itself, the person, the person can easily identify which part to cut, which part to leave, like that. But whereas in case of decision trees, we have to use some statistical methods. Based on that, we can decide whether to cut that branch or not. So pruned trees are usually faster and better at correctly classifying unseen tuples than unpruned trees. So compared to unpruned trees, pruned trees are a little faster and better at correctly classifying. So the pruned trees having good accuracy as well as they are doing their work faster than the unpruned trees. And we're having two concepts of tree pruning, pre-pruning and post-pruning. So let's take a decision tree. Suppose this is a decision tree. There are two concepts, pre-pruning, post-pruning. What is meant by post-pruning? Just observe the terms. I don't want the exact meaning. Just observe the terms, pre-pruning, post-pruning. Post-pruning. What is meant by anybody? What is meant by pre-pruning? What is meant by post-pruning? These topics are not yet covered, but you can try to explore yourself. ఏమై ఉండొచ్చు? What is meant by, what may be the meaning of the term pre-pruning? What may be the meaning of the term post-pruning? Any guess? Any guess?
అంటే ట్రీని బిల్డ్ చేస్తున్నప్పుడే లేబుల్స్ ని రిమూవ్ చేయడం మ్యామ్. పోస్ట్ ప్రూనింగ్ అంటే ఆఫ్టర్ ట్రీ బిల్డ్ చేసిన తర్వాత మ్యామ్.
Actually, I'm giving a big clap to you. Number 37. Very good. Pre-pruning, as the name itself indicates, suppose if you are going to do any work, we can generally use the terms prepone, postpone, like that, right? Here also, postpone in the sense doing the thing something later. Prepone in the sense doing the thing in the beginning itself. So here also the same concept. Here also the same concept. We are using the term pre-pruning and post-pruning. So as said by number 37, right? ఇప్పుడు చెప్పింది ఎవరు 37 అయినా?
Yes ma'am.
Very good, very good.
Yes,
So
ma'am.
yes, as said by 37, yes, pre-pruning in the sense we are pruning the tree before, that means at the time of construction itself. At the time of construction itself, we are going to prune the tree. We are going to remove the unnecessary branches at the time of construction itself. Whereas post-pruning, we are pruning the tree after constructing it. That means in the post-pruning, we just allow the tree to grow according to the data and according to the algorithm we have. And after the construction of the tree, we are again backtracking. We are again backtracking. We are again going back and observing the tree, and we have decided based on certain things. We have decided which branches to cut or which not to cut. That is in case of post-pruning. Whereas in case of pre-pruning, at the time of construction itself, suppose here is the tree, and here suppose we are at this point. Sorry, suppose we are at this point, and before going to develop further, we just want to decide whether this particular split at A3 is good or not, based on certain statistical measures. What are the measures we are having? Information gain, Gini index, gain ratio, etc., etc. They are for assessing the goodness of the split, whether that particular split is good or not. We can identify from the statistical measures by fixing a threshold. So we can initially fix a threshold, and based on that threshold, we can decide whether to go further. That means whether to branch here or we can stop here, like this. That is pre-pruning. So in pre-pruning, we are going to fix a threshold, but here, if it is too high, if the threshold fixed is too high, it results in oversimplified trees. If the threshold fixed is too low, it results in little simplified trees. That's why the said threshold should be of moderate value. It shouldn't be too high, it shouldn't be too low. So upon halting the construction, the node become the leaf node. So suppose we are halting the tree at this stage. Now we can conclude that this particular node become the leaf node in case of tree pruning. And coming to the post pruning, first we let the tree be constructed, or let the tree be grown as it is up to the extent possible. And after the tree is constructed, again we need to assess the goodness of the split based on certain statistical measures. So based on certain process, we can decide whether the particular branch is good, presence of the particular branch in the tree is good or not. If at all, for example, here, if at all you identified that this particular branch is an outlier, this is not necessary for that tree. In case of post pruning after construction, we have identified that. Then we just remove this particular subtree. We can remove this particular subtree. If you remove this particular subtree, what has to be replaced here? Here we need to remove this subtree, and we need to replace it with a leaf node. We need to attach it with a leaf node. Then what may be the leaf node in case of post pruning? What may be the leaf node? If you remove this subtree, then we need to identify the number of leaves, actually number of labels here, and the majority of the label can be added as a leaf node. So how many labels are there for this particular subtree? We are having 3 labels are there. For this particular subtree, we are having 3 labels, and out of 3, what is the majority? Majority label.
Class B.
Class B. So simply we can remove this subtree and we can attach class B here. That means we can label it as class B. We are removing this. So like this we can, after removing, we need to attach the leaf node for each and every branch where the subtree is removed. In this way, we can have pre-pruning and post-pruning techniques. So irrespective of the pre-pruning or post-pruning, the pruning of a tree can help to make the classification process faster and helps to getting the accurate and good results. So here are some theoretical part regarding pre-pruning and post-pruning. There are 2 common approaches to tree pruning. So pre-pruning and post-pruning. So coming to the pre-pruning, here a tree is pruned by halting its construction early by using the measures such as statistical significance, information gain, Gini index, and so on to assess the goodness of the split based on a pre-specified threshold. So high thresholds could result in simplified trees, whereas low thresholds could result in very little simplification. Upon halting, the node becomes a leaf node. So the leaf may hold the most frequent class among the subset of the tuples. So here is the post pruning. So it prunes subtrees from a fully grown tree by removing its branches and replacing it with a leaf. So the leaf is labeled with the most frequent class, the subtree being replaced. For example, to prune subtree at node A3, the same example here we have taken. So to prune subtree at node A3, the leaf node class B is attached to it, as it is the most common class within the tree, within the subtree. My screen is visible, right?
Yes, ma'am.
Okay. For this class, we have faced some internet connectivity problem. Since LAN is not working, I am connected through hotspot only. Okay. So, compared to the trees, which tree will give the accurate result? Up to our knowledge, which we got from the topic of tree pruning. Chapali, which tree will give the accurate result?
Small tree, ma'am.
Secondary, ma'am.
Secondary. Why? Because that is pruned tree. So we know that the pruned tree is better than the unpruned tree in all aspects. So here, coming to the last concept of the decision trees, scalability and decision tree induction. So how scalable is the decision tree induction? What is meant by scalable? Wherever you heard the word scalability, which means that what happens if at all the size of the data set is grown? If at all you have the largest data size, what happens then with decision tree classifier? So let's see that. The efficiency of existing decision tree algorithms. What are the existing algorithms? ID3, we know that C4.5 and CART has been well established for relatively small data sets as they have the restriction that the training tuples should reside in memory. So in order to execute the decision tree, the training data set, in our example, we usually call the D as the training data set. That training data set should be in main memory. That is the primary condition. So what happened if at all the data set is too high? It is very difficult it is very difficult to hold the entire big data set in the main memory. So it leads to some scalability issues for the decision tree. So in data mining applications, very large training sets of millions of tuples are common in general. So for large databases, the training data may not fit in memory, and hence swapping of the training tuples in and out of memory and cache memories is needed. Therefore, decision tree construction becomes inefficient in case of larger data sets. So we have some earlier strategies like discrete and continuous valued attributes and sampling data at each node for handling the scalability issue, but they are not sophisticated. And we are having some algorithms for the induction of decision trees from very large training sets. Those are SLIQ and SPRINT, sprint. So this is about the decision tree induction. And let's move to the topic of Bayesian classification. So just now we have finished the decision tree classifiers. So what is decision tree classifiers actually? I'm just rewind for a while. Decision tree classification. So here in decision tree classification, first we are having a list of all attributes. That is called attribute list. And from that, using attribute selection measure process, we are going to select the root node. And after the root node, the data set is partitioned into different parts based on the values of that attribute. And after partitioning, at each branch, again, the same decision tree construction algorithm is called to build the subtrees. And this process is repeated further. So once the attribute is selected as the root attribute, it is removed from the list of attributes. So what is the attribute selection measure process? So that process includes three measures. Here the scenarios of the type of based on the type of the attributes. We already know that split point, splitting subset, and case one is the general one, general case. So we are having three measures for that: information gain, gain ratio, and Gini index. And information gain, we have a entropy for measuring the uncertainty of the present in the data set. And our goal is to reduce the entropy, thereby increase the information gain. So we need to find out gain value for each attribute. And the attribute with the highest information gain can be selected as the root attribute here. So its main drawback is it is biased towards the multi-valued attribute. And coming to the gain ratio, so here it biases. That means it overcomes the problem of biasing towards the attribute with the multiple values. So it is a kind of normalization of the information gain with the split information. So here we have used the concept of split information. And next measure we are having is the Gini index. It supports only binary split. So since it supports only binary split, here we are going to use only split point splitting subset. Those two options we are having. So it is also measures the uncertainty of the attribute. And our main goal is to reduce the Gini index of the split. and to increase the Gini index of the overall variable. So here are some examples they have done, and this is the tree pruning. In tree pruning, we need to eliminate the noisy or outliers from the tree. So we are having there are two techniques under this: pre-pruning and post-pruning. So we can go into any of the ways. And next classifier is Bayesian classification. Bayesian classifier or Bayesian classification. So Bayesian classifiers predict class membership probabilities, such as the probability that a given tuple belongs to a particular class. So what is the main aim of classification? Any classification, either Bayesian or Bayesian, what is the main aim? To classify a tuple. That means to predict the class of the tuple observation. That means here class membership probability in the sense finding the probability of a given tuple X. That means it belongs to which class? It is a member of which class? That belongingness is here referred as class membership probabilities. So in this particular classification, the process of finding the class level of the given tuple X is referred as class membership, finding the class membership probabilities. So mainly Bayesian classification is based on Bayes' theorem. This is important. So Bayesian classifiers have exhibited high accuracy and speed when applied to large databases. That means it supports large databases also. And there are two popular classifiers under Bayesian classification: Bayesian classifier and Bayesian belief network classifier. Coming to the Bayesian classifier, it is a simple Bayesian classifier that makes the assumption of class conditional independence. This is very important. We need to know about this. What is this class conditional independence? So, where class conditional independence is that the effect of an attribute value on a given class is independent of the values of the other attribute. That means the class conditional independence says that each attribute of the dataset is independent of the other attribute. Each attribute is independent of the other attribute. For example, if you're having some dataset is like this, and one tuple consisting of your birthday, one consisting of your birth month, and one attribute consisting of year, and another attribute consisting of age. So I can say that the fourth attribute is dependent on these three attributes, right or wrong? This is your birthday. Day in the sense date. This is your birth month and this is your birth year. I can say like this, this particular attribute A4 is dependent on A1, A2, A3, right or not? Can I say like that?
Yes, ma'am.
Yes. Why? Because how we can calculate is based on the birth, year, and then month, and then particular date. That means a day. So these three factors are associated with the fourth attribute. This is the dependency among the, this indicates the dependency among the attributes. But here navigation assumes that there is an independence relation exists among the attributes of the given dataset. So whatever may be the given dataset, the attributes from the dataset, all the attributes belonging to the dataset are independent to each other. There is no relationship, there is no dependency among the attributes. That is only the assumption. That is not true actually. That is the assumption taken by the navigation algorithm, navigation classifier. So because of that assumption, it reduces the complexity of the complexity of the classifier, complexity of identifying the class level for the particular observation. So if at all the dataset really consisting of all independent attributes, then for that particular dataset, navigation classifier obviously give the good result. Why? Because it also assumes the same. But if at all, in general, if you observe any kind of data set, in general, there is a little dependency among the attributes. So here, the Bayesian belief networks allows dependencies among the attributes. Just observe the difference between two. Navigation classifier is a simple Bayesian classifier that makes the assumption of class conditional independence. What is it? This class conditional independence means the effect of an attribute value on a given class is independent of the values of the other attributes. So that is the assumption made by the navigation classifier. Why it made that assumption? In the sense to make the simplification more easier, to reduce the complexity of the algorithm. It assumes like that. But the second one, Bayesian belief network classifier, allow dependencies among the attributes. That means they are not assuming like that. They allow the dependencies. That means the Bayesian belief network assumes that, or it believes that there is a dependency exists among the attributes. So quite opposite to the navigation classifier. So we need to go for both navigation and Bayesian belief networks. And one more thing here, this Bayesian classification is based on Bayes theorem. All of you who heard the word Bayes theorem? I don't ask any formulas. Heard the word or not? Just vinnara leda Bayes theorem ane word? Is the screen is visible? వాటికి కూడా రెస్పాన్స్ ఇవ్వడానికి చాలా కష్టపడిపోతున్నారు. So this Bayesian classification is based on Bayes theorem. What is Bayes theorem? First we need to know that. So Bayes theorem is named after a British mathematician, Thomas Bayes, during 18th century. It is a mathematical formula for determining the conditional probability. So for classification problems, we want to determine posterior probability P of H by X of H conditioned on X, and is given here posterior probability of H conditioned on X is equal to P of X by H, P of H E of X. So here this is posterior probability of H for hypothesis, X for observation. Posterior probability of H given X, and this is posterior probability of X given H, and this is prior probability of H, and this is called prior probability of X. Just know the terminology. This is the posterior probability of H given X, and this is the posterior probability of X given H, and this is the prior probability of H, and this is the prior probability of X. And here H is the hypothesis, and which says that the observation X belongs to class C. That is the hypothesis. So this is the Bayes theorem. Let's take an example. If the observation is like this, if the given example, the customer age is 35 and income is 45,000, and hypothesis is that customer buys the computer. Then we are having these things, right? Posterior probability of H given X, which means that, what does this mean? Posterior probability of H given X. That means probability of buying a computer given age of the customer is 35 and income of the customer is 45,000. Next, P of X by H. That means posterior probability of the customer having the age 25 and income 45,000, given that he is going to buy the computer. Which means that if a customer buys the computer, then his age is 35 and his income is 45,000. Whereas P of H, that means prior probability of the class, P of H. That means it is completely independent of the customer's age and income. So probability that a given customer will buy a computer, irrespective of his age and income. So coming to this P of X, so it is independent of the class. This is independent of the class. That means the probability that a person from the set of customers is having the age 25 and having the salary of 45,000. So these are the terminologies we are having in Bayes theorem. And now we are going to use that Bayes theorem in navigation classification. And coming to the navigation classification, here we are having some terminologies. D is, we already know this, right? D is labeled training set, and N is the number of attributes, and A1 to AN is attribute set, and M is the number of classes, and those M number of classes are from C1 to Cm, and X is tuple, we already know this. Since we are having N attributes, X having how many values generally? N values, right or wrong? This is also called attribute vector. We are having N attributes means a single tuple may have N number of values, one value for one attribute. X1 is the value of A1, X2 is the value of A2, Xn is the value of AN, like this. Let me share the whiteboard so that we can get a clear view about the navigation class. So navigation classification. So here is the Bayesian formula. So here the condition is that here if a tuple X belongs to Ci in navigation classifier, what is the aim of the any classifier? To predict the class label for the given tuple. So here in navigation classifier, if the tuple X belongs to particular class Ci, then the posterior probability of a class should be like this. The posterior probability of that particular class is, let's say it is Ci, given that tuple X. So the posterior probability of the class should be higher than the remaining all posterior probability of the other classes. So what is the one and only condition here? If you get this point, you can able to get the details of navigation class. So you can understand that. Just focus on this. So here we are having a tuple X, and we are assuming that one of the class out of many classes we are having one out of that one of the class is Ci. If I can say that the tuple X belongs to the class Ci, when I can say that the posterior probability of the class given that tuple should be very high compared to the remaining. The remaining in the sense what? We are having that means compared to the posterior probabilities of the other classes. Suppose we are having classes like C1, C2, C3. What is the posterior probability of class C1? P of C1 by X. Class C2? C2 by X. Class C3? P of C3 by X, and so on. We are having some N number of classes, I think. So what is the navigation condition? So if at all, if this is the this is the hypothesis. That means X belongs to the class Ci. So to make this true, what is the condition? So మనం ఒక టపుల్ తీసుకున్నాం, ఆ టపుల్ Ci సంబంధించింది అని ఎప్పుడు చెప్పగలుగుతాం? What is the condition to make that condition true? So the posterior probability of that particular class with respect to the tuple should be greater than all the remaining posterior probabilities of the remaining all the classes. Did you get my point or not? So I can write it like this. Yes, I can write it like this. P of Ci by X in the sense given X should be greater than the posterior probability of Cj given X, where this J is in between 1 and m, and one more thing, J not equal to I. Right or not? This is comma. Did you get that? Get my point or not? How I can write this? It says that posterior probability of the class Ci given X should be greater than all the remaining posterior probabilities given X, where what is the value of J? Cj, J may be 1, 2, 3, whatever. Why? Because here is the expansion of J actually. If you replace J with 1, you can get this. If you replace J with 2, you can replace J with 3, etc., up to M. Why? Because we are having M classes. I have seen the notations in the PPT just now, right? We are having out of M classes, out of M, we need to compare this particular one with all the remaining posterior probabilities. If at all this is having the highest value, then we can conclude that. What is the conclusion? The tuple X belongs to the class Ci. Otherwise, we can't classify the tuple. Suppose I can say that there is a class Ca. If suppose X belongs to the class Ca, then what is the condition? The posterior probability of the class Ca given X should be greater than all the remaining posterior probabilities present in the all the remaining posterior probabilities of the classes present in the data set. So if there is only two classes, S class is there and no class is there. So if I can say that, if I said that the posterior probability of the class, if the tuple X belongs to the S class, I just want to prove that, then what is the condition? The posterior probability of the S class given the tuple X should be greater than the posterior probability of the no class given the tuple X. Because we are only having two classes, no need to go for all these expansions. This is for m number of classes. But in this example particularly, we only having the how many classes? Two classes only we are having. So for two classes, if I say that my tuple X belongs to class S, then its posterior probability should be greater than this. So if I say that my tuple X belongs to no class, then what is the condition I need to prove? The posterior probability of the no class given X should be greater than posterior probability of the S class given X, right or not? Are you getting my point or not?
Yes, ma'am.
This is little confusing, but it's very important to proceed further. It's very important to proceed further. So our task is now we need to find the what's our task actually here? Our task is we need to find the posterior probability of every class we need to find given X. Let's say either I or whatever. We need to find the posterior probability of every class. Suppose here we are having two classes. We need to find out P of S by X, we need to find out. P of no by X, we need to find out. And based on the value, we need to, that means the one which got the highest value, we can assign the tuple to that class. If at all, suppose I am having three classes, some class C1, C2, C3. Then I'm having three classes, C1, C2, C3. So how can I assess the class of X? What is the class of X? How can I find out?
Posterior probability of the all classes.
So just I want, before finalizing the class of X, I need to find out the posterior probability of all classes. That means posterior probability of C1 I need to find out, posterior probability of C2 I need to find out, posterior probability of C3 I need to find out. And suppose if its value is highest than other two, I can set like this: X belongs to C2. If this value is highest, I can set like this: X belongs to C1. So what's the conclusion? So in order to classify the tuple to the appropriate class, we need to find out the posterior probability of the each and every class given the tuple with respect to the given tuple. Is it clear or not? Is it okay up till now?
Yes, ma'am.
Okay, I will continue in the next class, and also in the next, today I'm having some net connectivity. That's why I'm not going to ask the assignment which I have given. That means finding out the Gini index, right? So attendance for this class is I'm providing for every attendee. Every participant is provided with full attendance for this class, and for the probably in the next class I will ask about that. So I will ask about that, and each, as said in the last class, each group, one of the members from each group should be able to present your process of calculating Gini index in the next class, mostly based on the net issue, because in this class I'm having net connectivity problem. That's why I'm not rising about that. I'm not asking about that. Maybe probably in the next class, I will ask you if at all my connectivity problem is settled. I will ask you regarding that. And ఈ క్లాస్ కి అయితే నేను ఫుల్ అటెండెన్స్ ఇచ్చేస్తున్నాను. నేను ఇప్పుడు ఏం అడగలేదు కాబట్టి